So, uh, I have to introduce myself, I think, as per introduction. I mean, as per the instruction given to me. So, I am Shripan Mandal. I am working as a research scholar, as a PMRF in IIT BHU Varanasi, and this is one of my deliverables towards the PMRF scheme, which I am involved of. So, today I am going to conduct the third week of this live session. What the motive is, I will discuss the problems given in the previous year assignments, and the discussion may or might help you to solve the assignments given in this year. So for the week 3, I have only 4 to 5 questions that I have to discuss. So the first question is it visible to all of you? Can you read the question properly? Hello?
Yeah, sir. Above
Okay, so the question is that suppose there is a set of random numbers, say x, which will be between 0 and 1. So if you call the random underscore number that subroutine already inbuilt in the Fortran, that will generate a set of random numbers which will lie in between 0 and 1, which will follow an uniform distribution, which means that each one of those number will have the same probability to happen or to be the outcome of your call of that subroutine. Okay, so if you call that subroutine, it will generate random numbers between 0 and 1. And then here are two questions. First one is the above random numbers which are between 0 and 1 and following a uniform distribution, can you convert it to a set of random numbers with uniform distribution and lying between 5 and 10? So what happens is, in this question you see the distribution which is followed by the random numbers, the set of random numbers, that will remain same, just the lower and upper range of those random numbers have to be changed. Okay, so can anyone tell me, let's say Gaffer, first you
yeah,
can
sir.
try how to deal
Second
with this
one, sir.
question.
Second one, sir. 5x plus x.
So how you can say that?
Sir, if we take the lowest value 0, then it will give the 5.
Yeah.
If we take 1, it will give 10.
Okay, so that is quite easy, right, for this question.
Yeah.
So the method which we can use is that is my solution is visible here.
Yeah.
Yeah.
No, okay.
Is it visible?
Yeah, sir.
Yeah. So yeah. So the fact is, let's say you have two distributions, right? One is for x, another is for y. So what happens that the conservation of probability tells us that px dx equals to py dy for the for two different distributions, and from there you see that if x is following an uniform distribution, then px will be 1 for 0 to 1, the limit to be 0 to 1, and from there on we can just a minute. Yeah, so from there on we can have this equation which will give us the cumulative distribution function. This equation is called as cumulative distribution function, and you see the lower limit is given to be a for general course, but for this question it will be substituted by 5, and the upper limit is not the exact limit what the question is telling, that is 10. It will be take a random y, or more in general number y, and then this is defined in this way. And what we can do is we have to consider the normalization criteria also, which means that if we have a function like px, and if we integrate it minus infinity to plus infinity, then it will give us 1. So for this case it will be 0 to 1 px dx that will be 1. Similarly, if we look at this, that 5 to 10, so what the question is suggesting that if we are generating the random numbers say y, and all of them should lie between 5 and 10, then the total probability of those random numbers should be 1. But here you see it will be equated to be 5, but by definition it should be 1. So what we can have to do, that we have to multiply this py by a normalization constant for this case, which will be 1 by 5. Okay, Gaffer?
Okay, sir. Okay.
Yeah. So sorry. So what I do, that just multiply the function, and since this is a uniform random distribution, then py prime can be taken as 1 for the range to be 5 to 10, and for this case then dy prime you can calculate just by integrating that, and that will give you this value, and then I can substitute the value of n from this 1 by 5, and we will get this type of a equation. Okay, and from there we can write the y in terms of this. So it is quite easy for this particular problem, that you can just already see the solutions and see the options and give the answer. But this is the way to do if we have some complex type of thinking, so okay, complex type of questions we are facing. So this is the process you have to follow. Okay, Ankita, sorry, Archana.
Yes.
Okay, yeah. So let's move on to the next question. So here you see that here already you have that x random numbers which are lying between 0 to 1 and following the uniform distribution. But here you are, the question is giving that you have to generate a new set of random numbers which will follow an exponential distribution, not the uniform distribution like the last question. So here the distribution say py, that will have some other forms that cannot be equated to be 1. Okay, so Gaffer, can you tell us how to do that right now?
Sir, in the second we took the py equal to 1. There we
Yeah.
have to substitute the exponential term.
Okay, so can anyone solve it?
Yeah, sir. We okay.
So can you solve and show the solution?
Okay.
So everyone can solve it by their
Yeah.
own. Archana, you can also try.
Yeah.
Okay.
Shukran, can you please show the slide, earlier slide, where you attempt?
Yes, yes,
Yeah.
yes.
Okay.
5 to 10.
Of course, in this equation, we have the in the similar equations we should go for the second step and integration e to the power minus 3y dy, right?
Yes,
Or
yes.
yeah, so that integration will give us 1 by 3 into n, right?
1 by 3.
Yeah,
How?
because e to the power minus infinity is going to give us 0, then e to the power 0 is going to give us
1.
1.
Yeah.
Yeah, so it will be minus n by 3. X equal to, if I look into the first part of this expressions in this, whatever way you have done in the first problem, this one, whatever is displayed in here,
Yes.
x is equal to, so finally we will get minus 1 by 3 into n, right?
Here it will be like this one. Let's say you have x,
Yeah,
and then you
yeah.
are since this is cumulative distribution function, you
Because it is
need not
given
to take
y,
you need not to
y,
take this infinity. Okay, but whenever you are taking the normalization condition, then you have
okay,
to take this like this one.
okay, so
Okay.
here it will go from 0 to 1, right? That
Yeah,
means,
0 to infinity in this case, and this will be 0 to y.
yeah, so 0 to 1, then it will be, then not, n into, n into,
Exponential
uh,
minus 6y dy,
yes,
and the
yes,
limit will be 0 to y. Okay.
yes.
Yeah.
Oh, sorry, I actually considering this factor to be 3, just like the questions given. You have given here as e to the power minus 6y. I was considering as e to the power minus 3y.
No, no. The question is
Okay, so yeah,
given. The question is given.
into power of minus.
yeah, I understood.
So here it is
In
given
that,
minus
yeah.
6x. So I think there will be
Oh,
some mistake in this question. This will be minus 6y maybe.
actually, I was considering the problem given in the assignment. There it was given as e to the power minus 3y.
No, no.
Anyway,
I
okay.
am just solving the
Yeah, sure.
questions from previous year.
Okay, okay.
Yeah.
So, yeah,
Into infinity.
right.
So,
Gaffer.
yeah, sir.
So
So,
what is the progress?
uh,
So what I have done in this question, I think the process is correct, but the answer I am getting is not matching with any of the options given.
अच्छा,
So maybe there is some mistake with the options here.
okay, okay.
So you can check by yourself also. And actually, the process is taken from those lectures given by the faculties. So I feel I am doing right, and that's why I'm giving both of you to cross check on yours.
Okay. So, minus 1 by 6. The fourth one.
Archana, what are you getting?
So, ask.
Archana,
The last one,
the last
right?
one. You are
Yeah.
getting the last one. Yeah, I was also getting the last one. But yeah, the answer was given the third one. But sorry, the first one. So I think there will be some mistake.
Third one. No, third one.
No, no, the first one. So I think there will be some mistake on They are.
No, what I'm saying, I got the third one.
You got the third one.
Positive, yeah, positive marks. The plus 1/6, not minus 1/6.
So can you show the answer? I think.
Sorry, it's a minus. Yeah, I missed a minus. Yeah, minus 1/6. Actually, I was doing in my copy, so how to show it?
You can. I think you can check for on your video, and you can show it. Just have a try whether you are able
Okay.
to show it. Yeah. So yes.
Yeah, this is minus sign will be there. I missed the minus sign.
Okay. Okay. Yeah. So. Yeah, I have did in this fashion also.
So this is the last one will be the answer.
Okay. Okay. Fine. Gapar.
Yeah, sir. 1 minus 6x.
Mm-hmm.
Sir, minus 1/6 will come.
Okay. Fine.
Minus 1/6 log of 1 minus x.
Okay. Okay. And how do we define the limits here?
Limits y goes to 0 to infinity means infinite. So here 0 means log 1 0. From 0.
So for exponential distribution, what will happen? The lower range will be 0 and upper will be infinity. So y will have a lower range of 0 and upper range has to be infinity, right? So if you look at the 0 for x, then it will give you ln 1, right? So which will be 0. And for 1/6, it will be ln 0, and that will give you infinity. Okay?
1/6.
ln 0, that will give you 1 minus 6x. So if you put x to be 1/6, then it will be 1 minus 1, right?
0.
Yeah.
ln 0.
Okay.
0/6.
ln 0 it will be infinity, right? Archana?
1/0.
Archana?
1/0.
Yes.
Yeah, so any issue here?
No, thank you. Done.
Okay. So let's move on to the next question. Gappar, are you okay with this?
So this limit infinite will come.
Yes.
Infinite.
And y has to be the infinite, the limit has to be 0 and infinity.
Minus 1/6.
So you have to put those value of x so that y will be the values to 0 to infinity. Okay. Okay.
Yeah, sir. This.
So this is the process to do the questions.
Sir, ln 0 value what it will give? ln 0.
ln 0 will give you infinity. Okay.
Infinite. Acha, infinite by 6. Okay.
Okay. So let's move on to the next question. Fine. So this will a straightforward question that the cumulative probability distribution function of a Gaussian distribution is a. So here are 4 options. You have to tell which one is the correct.
Yeah, gosh.
Can you tell me? Okay, let's ask Jitender. Hello, Jitender.
Hello, good evening, sir.
Good evening. So, can you tell us the answer for this question?
Okay, I will try.
So, tell us first that how you are going to define mathematically a cumulative probability distribution function. Anyone? Archana? Can you tell us which will be the answer for this
Sir.
question?
Hello, sir.
Yeah.
I think it will be a Gaussian function.
How you are so sure?
Sir, like what I thought that Gaussian distribution, it is like bell-shaped curve. Okay,
Yeah.
so the probability of middle value is maximum, right?
Mm-hmm.
So it is written the cumulative probability.
Mm-hmm.
So initially it will be low and then it will rise, and again I think I'm wrong.
See, when we are dealing with the probability distribution function without this cumulative term, okay, then the limit will be like this. For Gaussian function, this will be for infinity to infinity, okay. But when we are dealing with this cumulative term, then it will be like 0 to certain value of y prime, okay. So this will be cumulative and this will be the probability distribution function, which is known as PDF. Fine, this is a difference. And as we seen in the last two questions, we are going to define these things like this: x equals to, say, let's say a 0 is a particular number, let's say y prime, and then py dy, correct? So this way we are going to define a cumulative probability distribution function. Fine. Now what we need to do, we need to write the form of py from this Gaussian distribution, okay. So what we are going to do here is, let's say a to y prime, okay, and py will have a form like exponential minus y square by 2 dy, okay. So here we are taking the mean of the Gaussian distribution to be capital Y, which will be equals to 0, okay. Fine. So the exact form of this Gaussian distribution will have like this: exponential minus y minus capital Y square by 2 sigma square. Fine. And here you see y, capital Y is taken to be 0 and the sigma is taken to be 1, okay. Okay everyone, so now you have this equation, okay. Can you tell us which kind of equation is this with this limit, and let's say a to be 0 here for convenience. Now you have a finite limit instead of infinity, and you have this kind of a equation, and from there you can do another thing, that you can take y by root 2 to be a certain, say y by root 2 can be taken as z, okay. So from there you can have a certain function like exponential minus z square dz along with some other constants, but this integrand with some finite limit, that will give us the error function, right? So error function will have like er if, let's say, z, that will be defined as 0 to z exponential minus t square dt, right? Okay, so this is the definition of error function. And if you change this y by root 2, let's say this is root 2 to be z, then you will get this form in the form of exponential minus z square dz, and this will be given by error function of y prime, right? If you resemble this with this, you can have the answer. Okay.
Yes, sir.
I thought the answer to be the last option because if it, since it does not mention whether this Gaussian distribution is normalized or what, I assume that the function will be normalized one. So if I consider this integration within this limit, that is going to give me unity, right? If I am not wrong.
Within this limit,
Yes. If it is the my function is given the
within
given
0 to y prime.
Yes, whatever range means. See, in the question, the
No,
Gaussian,
for Gaussian distribution, if you need to be equate the function's integration to be 1, then
Yes.
you would have this limit to be minus infinity to plus infinity. You
Plus
cannot
infinity.
say that
Yeah.
if you have the finite limits, then
Yes.
the integration cannot be 1. So normalization condition is true when the upper and lower limit is is convenient with the upper or lower limit for that particular distribution. And for
So
Gaussian
here-
distribution, this will be minus infinity to plus infinity, not
So in
like
this
0 to y prime.
in this case, since it has not mentioned, so we will be considering some, instead of minus infinity to plus infinity, we will be considering means a to b. That means what you are saying,
Yes.
right? So in that case, it will be an error function. Okay.
Yes.
Okay, thank you.
Yeah. So if you have like this cumulative term is not there, right? Then you can take that, okay, minus infinity to infinity can be your limit. But for cumulative thing, you have to take the limits to be this kind of finite, okay? And
Okay.
then you have this kind of a function and integration, which will
Okay.
resemble with error function, okay?
Okay. Okay.
Yeah. Thank you. So can we move on to the next question? Gappar, any question?
Yeah, yeah, okay, okay.
Jitender, any problem?
No, sir.
Okay, so you are understanding what I am telling.
Yes, sir, a little bit because actually today first time I'm joined this lecture. Okay.
Okay, okay. Okay, fine.
So I will go through this one again.
Yeah, yeah, fine. Thank you. So here is the next question. So here you have given a multidimensional integral which will integrate the integrand in the dx and dy, and so can anyone tell me first that what is importance sampling technique? What is meaning of this thing, importance sampling technique, and why we need that when we are doing the integration by Monte Carlo method? So let's first someone tell me what is the Monte Carlo method. Gappar.
Sir, it is said last class that we are integration. We are by taking random points. Integration we are going to perform by taking the distribution,
Correct.
mean values, average values.
Correct. So let's say we have a plot like this, right? And you have a graph like this, and you need to calculate the area under the curve for this integration, right? This will give you the value of the integration, correct? So what we can do is, in the brute way, we can take a rectangle kind of shape, okay, and you can generate the random numbers within this with, let's say, this will be, let's say, 0 to 1, or let's say any arbitrary range, let's say a to b, and you are generating it to be uniformly. So each one of these random numbers will have uniform probability to be of the outcome. Okay, so what happens that if you have a distribution or the profile of your integrand to be this kind, okay, instead of this type of shape. So if you have this localized shape and you are taking again this kind of a rectangle there, fine, and if you are generating the uniform random numbers, then if you have this random numbers like this, each one of these random numbers will have uniform probability, and the sampling of the random numbers within this particular profile of the function will be very less, right? So this sampling of random numbers outside this particular profile will not have any contribution towards the integration, and that value of the integration will be very much deviated from the exact value of this integral for this particular kind of a profile. Let's say this is a Gaussian kind of profile. Then you cannot do the integration by this Monte Carlo method using this brute technique to be considered the uniform random distribution to be the particular way to generate your random numbers. Okay, so instead of that, you have to use this importance sampling technique, and there you can generate the distribution to be resembling a Gaussian shape, or let's say an exponential distribution, or let's say any distribution which will resembling the particular profile of this particular function. Okay, so in importance sampling technique, you have to took a particular distribution function which will be likewise your given integrand. Okay, so here you see this is your given integrand, right? Exponential minus x square plus y square minus xy by modulus of x minus y. Okay, so which one of this probability distribution will be your correct choice?
So Gaussian one.
So this will be Gaussian one, right? So if you take the Gaussian one, what will happen that you are going to divide this function by exponential minus x square plus y square, and that will what will be result of that? Your integrand will be simplified from this form, and also if you divide this by exponential minus x square plus y square, then it will have to be multiplied here before the dx dy, and that multiplication along with dx dy, that will be integrated like a Gaussian term, right? So that will be simplified for this function. So Gaussian will be the correct answer for this question. Okay, Gapar?
Yeah, okay, sir.
Jitender, any problem?
No, sir.
Okay. So let's move on to the next question. So here the question is that suppose we want to integrate I equals to 0 to 1. So here you have a limit which is 0 to 1 and x to the power minus 1/3 plus x by 10 dx using importance sampling. Again you have that importance sampling comes in. So what would be a good choice of the probability distribution function of the random numbers? So initially what I was doing for this question is I was taking some change of variable, right? So what we can do, let's say we are taking px to be a particular value, and what will happen in the importance sampling is the exact procedure is like this. Let's say you have a limit of something a to b, and you have a function like fx dx. Okay, yeah, so fx dx, what will happen is in the importance sampling a to b, you can generate like this: fx by px, that particular distribution function, then px and dx. Okay, so for this case what you have to do, that divide this one by one of this, and which will give you a particular good change of this expression, which will be the better one for this calculation. Okay, so let's say if you take the first one, which will have the exponential minus x to the power 1/3, that will complicate your equation, right? That will not simplify your equation, because you have already x to the power minus 1/3, and then you are taking exponential minus x to the power 1/3, then it will be more complicated for this process, right? So this cannot be a good choice. Okay, and also you can see that if you are going to take this probability distribution function to be like this one, say exponential something, then you are basically taking some probability distribution which is resembling for the exponential distribution, and for that case you have to be maintain this limit to be 0 to infinity again. So you have to change many things if you choose this to be the distribution function. Okay, now if we took this 2 to the power 3, 2 by 3 to the power minus 1/3, then what we will see, that if you do that, then x to the power minus 1/3 by x to the power minus 1/3, that will give you 1, and you are left with just 3 by 2, because this is 1 by 2 by 3, so that will give you 3 by 2, and here ax by x to the power minus 1/3, which will give you something like 4 by 3 kind of a thing, right? So, and again if you do the, let's say if you take this x to the power minus 1/3 plus x by 10 to be z. Okay, if you are changing to changing the variable, then if you take the derivative on the both sides, then it will be like minus 1/3 and what will be it, what it will be, hello, hello,
Yes. X plus x.
so you can check by yourselves also. So I have done through some programming here, so let me tell that. So this is the motive to do this calculation, how we can. So first you can check by analytical power, and then you can write the code for this particular thing, and you can check for the errors from the actual value and the value are getting from this. Okay, so here is my programming that I am going to tell how to do this. So let's say you have a program, and as before I am going to define the type of the all the elements used in this program, and then I am getting the actual value of this integration to be by doing that to be analytically. So that will be around 31 by 20. You can do that by yourself also. And then what I am doing, that I am opening a file which I will use for store the generated values of our integration for different values of n, and n is the number of random numbers. So how many random numbers we are going to generate, that will help us to help us to have the error minimized. Okay, so firstly we are giving the chance to prompt or the user to write the value of the n, and then what we do, we are leveling this line to be say 11. You can take any number except 5 or 6. Okay, you can take 7, 8, 9. And what we do later on, we are going to this particular line until that n is less than this figure. Okay, so until the n is less than this, so we are going to this 11th line, and we are doing this for each of the value of the n. So for particular n, let's say n equals to 1, we are doing this, and then again n equals to 10, we are doing this, since n equals to n into 10. So for each step you are increasing the value of the n to be n times, so to be 10 times for the previous one. Okay, so firstly we are considering that, okay, the integration value which we are getting through the Monte Carlo simulation to be 0, and then what we are doing, that we are calling a random number, say p. Since this is a one-dimensional integration, you have to generate only one random numbers for a particular value of n. Okay, so it will give you the and then what I do it, that you need to change that to be 3/20 into p, since that will be the limit of the integration in this case. Since this will generate the random numbers to be 0 to in between 0 to 1, and you need the upper limit to be 3/20. So I am just multiplying that to manipulating our random numbers. Okay, and then I am using that method of Monte Carlo simulation, and I am going to add my function for those particular x values which are completely random in sense, and this function x is defined in this way. Okay, here you see I am going to define the function in such a way which will be my functional form, when I am going to divide the given function by the px for this choice. Okay, so this will be the function when we are dividing the given function by the px value we are using, and that will be our function. Okay, and we say that this is the way we are going to have the integration value through the Monte Carlo simulation. Also we can calculate the sigma, which will give us the standard deviation, and then what we did is we are taking the average of those the summation of integral MC, and that will give me the integration value. Also I am calculating the error with the integral MC minus actual, and I am taking the absolute of that, so that will give us the error for this particular calculation. So for a particular n, we have all this calculation have been done, and then I am increasing n to be 10 times of the previous n, and I am calculating or running this code until the n is less than this particular number. Okay, and also I am defining the function here. So what I have is, for let's say 1 and then 10, so these are the values of n. Okay, so this will the values of n, and for those values we have the integration value. So this int MC is printed here, and with the errors being this. Okay, so you can see that this value, this 31/20, that will be around 1.55, but here even if this n value is quite large, the integration value which we are getting from Monte Carlo simulation is almost 0.025 deviating from the actual value. So this is the reason that Monte Carlo simulation is used for the multidimensional equations or multidimensional integration. Here the dimension of the integration is just 1. So in those cases the trapezoidal rule or the grid based methods are the best one, because they give the error to be very small, and Monte Carlo simulations can be used for the multidimensional equations or the integrations. Okay, any questions, Gappar?
Yes, sir. No, sir.
So you understand?
Yeah, sir.
Yeah. Archana?
Yes, it's okay. Fine. Thank you.
Okay. Jitender?
Yes, sir.
Shreya?
Yes, sir.
You joined late, right?
Yes, sir.
Yeah. So uh, have you see the other videos, the 2 lecture videos? Hello, Shreya?
Yes, sir, I have.
Okay. So is it helpful for you to solve the assignments this year?
Yes, sir.
Okay, fine. So I think I am done. I have another question, but I think it's already discussed in the previous class. Here they just change the range of the values, +2 or -2. Last time it was given to be +1 or -1, and everything is the similar thing. So you can do this same programming, just change the values there. Okay. So that's it. So I hope Jitender, is this session helpful for you?
Yes, sir.
Okay, fine.
Sir,
Yes,
here,
Shripan.
Yeah,
small, sir,
Yeah,
small
Gaffar,
doubt.
carry on.
yeah,
Yeah, sir, we are using this f of x by px
yes, yes.
to convert that function, guys. Sir, into we are multiplying p of x, that we are not taking.
Why?
So we are to change that function, we are dividing by px and multiplying by
Yes, also
px.
we are taking that px in the multiplication. We are
That we
also
have to
taking.
take care that
Yes,
the
yes,
division
yeah,
that we have to take.
yes, yes, absolutely.
Think we have, sir, in program we consider that multiplication, no?
Yes, obviously, yeah.
I have to check once.
Mm-hmm. Yeah. Yes, Archana.
Yeah, Shripan, thank you for the session. I have a different question actually.
Mm-hmm.
Attending this solving session is not compulsory, right?
No, no,
Means
it's
as it depends, means if we find any difficulty in our assignments, then we can go for it,
yes,
right?
yes, yes,
Okay,
absolutely,
okay then. Okay,
absolutely.
okay.
Yeah.
Thank you.
Thank you. Okay, so I think I am done for today. So let's meet on next Sunday. I hope this will be useful for all of you.
Yeah, yeah.
So thank you very much.
Good evening.
Thank you,
So,
sir.
bye. Bye bye.